what about the use of RNA mechanism for the cancer research in the next future?
Yes, so hi Alessandra. So that of course the cancer vaccine has 20 years. If you look at back, first clinical trial were maybe mid 2000 when it started. So, but in animal studies it started in 20 years ago. And the challenges, of course, is much higher because it is difficult to identify what should be the target. As for the corona, you might know or not know, but the BioNTech, Pfizer, and the Moderna vaccine, both of them code for the same identical protein, the 1273 amino acid identical in both, because it is obvious, because that's what on the surface of the virus. So it is easier. For cancer, we hardly use antibody against cancer because the cancer cells are not making some kind of special protein, a big protein which the antibody can recognize. For that one, we need cellular immunity. But again, it is difficult that what mutation will generate amino acids, which will be presented in the MAC molecules, which will be characteristic for the cancer cells. And because there are so many different cancers and there are so many mutations, to identify which would be the driver mutation, it needs so much more science that we have to work. So if the expectation is that now that it was so easy for corona, now the next year will be against cancer, we need much more work to do. And this is the same when people ask me that, if HIV people are working so long, why they couldn't do it, But the understanding is when somebody has a viral infection and then survive that, they generate antibodies, and people start to investigate how it is formed, what is this antibody against. But when the HIV patient, they looked at the long-term survivors, it turned out that genetics were different. The CXCR5 mutation was there. You cannot vaccinate to introduce those to the people, although now it is a process for that. But the virus is so unique in a way also that it covered with sugars and other things, and you cannot make an antibody against. And the area where the HIV, let's say, you can target, that area is not as conserved, and the virus is constantly changing and finally exhausting the immune response. So each infectious disease, cancer, each of them needs a lot of scientists, and here we are talking to the students here. So hopefully they are coming and focusing on this kind of research so we can have a good outcome and good vaccine.